Let's take a look at our quadratic equation. We have talked a lot about linear equations. Remember, linear equations a lot of times take the form y equals mx plus b. That's a standard form, but there's other forms, of course. But what I want you to notice is that our x here is raised to the first power. It's linear. If we were to graph this, it would be a straight line. We've also worked a little bit on exponential functions. Remember, our exponential functions look different because they were raised to the x. Here our x was to the first power, and an exponential function, our exponent is our input values, our x. Exponential. In this chapter, we're going to be talking about the quadratic functions, our quadratic equation. What I want you to notice, this is an example, okay, and I'm sorry, this should not say when a equals 0, when a does not equal 0. Notice that this is raised to the second power. Linear is to the first power, exponential is to the x. Quadratic is going to be raised to the second power. That's how we identify it as a quadratic equation. Now, today we're going to be solving by finding square roots. Again, there are a number of ways to solve quadratic equations, but we're going to do that by finding square roots. This is a little hint here. Oops, there we go. And what this says is if d is greater than 0, what is d? That comes from right here. Excuse me. X squared equals d. Okay, so if our solution here, x squared equals d, if it's greater than 0, then it has two solutions. And I'll show you what this part means here. X is going to be the positive and negative square root of d. If d equals 0, so if we're saying x squared equals 0, then it has one solution, 0. If it's less than 0, then it has no real solution. Let me show you what I mean by that. Okay, if you look at these equations here, these are all considered quadratic equations. They look a little bit smaller than this here, but we can imagine that our coefficient of b and c here are 0, so they just are gone. When we say x squared equals 16, we're asking what number times itself, or what number squared equals 16. So you take the square root of 16, and hopefully you know that that's 4, but it's also a negative 4. Think about it. If we put 4 squared, that equals 16, but negative 4 times the negative 4 is also 16. That's what we mean here, that if it's a number greater than 0, it has two solutions. 16 is greater than 0, so it has two solutions. Here, x squared equals 11. Well, what number times itself equals 11? 11, the square root of 11 doesn't fall in our perfect squares list, so we would say the solution would be the square root of 11 and the negative square root of 11. Yes, and I'll point out real quick, guys, if you wanted to write these like that, that's fine as well. Always using the positive and negative sign. And we'll get back to the right screen here. Notice if we type this into our calculator, we would get an irrational number. We would have to round that. By leaving it as the positive square root of 11 and the negative square root of 11, that's an exact answer. So just understand when you get an irrational number, if it doesn't tell you to round, just kind of leave it alone. Okay? Look at this example here. X squared equals negative 4. What number times itself equals negative 4? Well, we've talked about this previously. There is no real number solution. There is a solution. It's called an imaginary number. No real number solution. So that's what that means here. If d is less than 0, then it has no real solution. And that's what you just write for this problem. No real solution. And again, I apologize that my stylus is kind of acting up here. Okay, and looking at the last one. This is a number greater than 0, so it's going to have two solutions. What number times itself equals 100? What is the square root of 100? Both positive and negative 10. Okay. So again, these are simple, easy quadratic equations we can solve by taking the square root. Let's look at another example. This says 120 minus 6x squared equals negative 30. Solve. This is an equation, ladies and gentlemen. We know how to solve equations. What are we solving for? This x squared here. So let's solve for the whole minus 6x squared. Get rid of the 120 by going minus 120. Whatever you do to one side, do to the other. This is the same rules we've always had for solving equations. Don't forget to bring down a negative 6x squared. And if you do negative 30 minus 120, or negative 30 plus a negative 120, you get a negative 150. Keep following your rules of solving equations. Divide each side by a negative 6. Negative 150 divided by a negative 6 is a positive 25. It's positive because you have a negative divided by a negative. And then you can say, okay, what number times itself equals 25? Or take the square root of both sides. Because remember, taking the square root undoes squaring something. And we get x equals both a positive and a negative 5. That means I could substitute both a positive and negative 5 in here, because either one would give me 25. Multiply that by 6, and go 120 minus that, and you get a negative 30. Same rules for solving equations. Just when you get to the x squared, then you're taking square roots. The last example we want to talk about is the falling object model. H equals a negative 16t squared plus s. When we look at this h here, that represents height. Usually measured or always measured in feet. In this equation, it's because of the negative 16 that takes into consideration gravity. That's why this is height in feet. And this t here, t represents time in seconds. And s represents the initial height. Okay, s represents the initial height. And this is the falling object model. So basically, if you're standing on something and you drop something, we can figure out either the time it takes to fall or how far it fell. It says using the falling object model to find out how long it takes a free fall ride at an amusement park to drop 121 feet. And we're going to assume there's no air resistance. So if we use our formula, this 121, that's our initial height. That's where we're starting from. We're dropping 121 feet. Now, we want to know how long it takes. So I want to know what t is. So what am I going to put in for this h? Well, if we're starting at 121 feet, where are we ending up? 0 feet. Okay, so when it hits the ground, or in this case, amusement park, it's not necessarily hitting the ground, but maybe hitting the bottom of the track or something, however you want to think of it. But we want to know how long it takes a free fall ride to drop. So basically, as low as it can go, and we're going to call that 0 feet. Solve this equation. Subtract 121 from each side. We'll end up with a negative 121 equals negative 16t squared. Divide both sides by a negative 16. And if you type negative 121 divided by negative 16 in your calculator, that comes out to 7.5625. That is not the time we need to take the square root of both sides. So we're going to get our time equals the square root of 7.5625. That is a positive 2.75 and a negative 2.75. In this case, though, with the falling object model, our negative answer doesn't make sense. We don't want to deal with a negative answer because how do we have a negative amount of time? So we're only concerned with our positive answer. So according to our model, when free falling from a height with no air resistance, height of 121 feet, it would take 2.75 seconds. Again, quadratics, ladies and gentlemen, the most simple, basic way to solve them, if possible, is to just use your knowledge of square roots.